Hi, my name is Rohan Pandit, and this is a presentation on software architecture which we made as part of our Software Engineering for Industry module this year. In this exercise, we were presented with the task of designing a ticket booking system for the Royal Albert Hall. As you can see on the slides, we created multiple views for the architecture, including the information view and the deployment view. Here you can see how the ticket manager, the booking manager, and the customers can interact with the system and how the data is stored on the databases. In the deployment view, you can see how the web apps interact with all the services in the clouds, such as the event service or the booking service and the ticket service. And the load balancer is used to ensure that the jobs are spread evenly across the different servers, and the cache can be used to improve the performance of the system, and how they interact with the different components on premises. Now let's take a look at some of the benefits of software architecture. Software architecture refers to the fundamental structures of a software system and the discipline of creating such structures and systems. There are many benefits to a good software architecture. It provides a solid foundation for the system, and it also improves the scalability of the system. It can reduce the overall costs of building the system, and it provides a vision for an IT future state. It gives better code maintainability, and it also enables quicker changes in the system. And it helps to manage complexity as well as reduces the overall development time. It can help to improve the performance of the system, and it helps to communicate with stakeholders and provides a reusable model for the different services, as well as serves as training for the team members. It can help to reduce the chances of risk and failure, and it helps to support early design decisions that impact a system's development, deployment, and maintenance life. And ultimately, it builds usable services for customers. Software architecture aims to address these main concerns. The first is maintainability. So, can the code be understood, modified, and improved over time? The interoperability. So, can it integrate and work with other systems and technologies? Scalability. So, can it handle an increased demand on the system? Security. Can it protect the system and its data from unauthorized access and malicious attacks? Performance. So, can it work in a fast and efficient manner in terms of computational and memory resources? And modularity. Can it be easily maintained and individual components be updated separately? So addressing these concerns at an architectural level and early in the design process ensures that the system can be flexible, reliable, and open to evolution as the requirements change. These are some of the most important architectural decisions that we took and the implications it had on the exercise. So firstly, we used microservices in our architecture. This ensured that there was scalability, resiliency, and ease of maintenance by allowing each service to be deployed, developed, and managed independently. We adopted an event-driven architecture for efficient communication between services. It provides a loosely coupled communication mechanism between services and allows for asynchronous processing. This is very important for a system that requires handling spikes in traffic. We achieved compliance with security and privacy regulations through encrypted communication and secure storage of sensitive data. Creating secure communication between servers, storing sensitive information in encrypted form, and following best practices for secure web development helps to gain more trust from customers. We also use load balancers for distributing traffic. Distributing traffic across multiple instances of each service ensures that there is high availability and resiliency. It can also aid better utilization of all resources. This makes the overall service more stable and is less likely to affect customers negatively. We also use a centralized database to store all the necessary information. This reduces the complexity, the communication overhead, and the initial maintenance as we are upgrading the system. So we likely already have a centralized database. We also implemented a cache layer to handle traffic spikes and reduce the load on the database. Handling spikes in traffic and reducing the load on the database by storing frequently accessed data, such as events and availability information, and serving it directly to users. Thank you for watching the presentation. Hopefully you found it useful and informative. This was just a brief introduction to software architecture, but if you want to learn more, you can have a look at the description for links to more articles and books. And feel free to share your thoughts in the comments below.